compose your quantum algorithm or quantum circuit, then you decide how to do the optimization. So it is not a kind of a rule that how to do the optimization. It depends on how your decomposition comes up. Circuits on spin torque based qubit architecture. So quantum Fourier transform, this way we can represent. Uh, if you look at it very carefully at the beginning of each control from the 3 qubit quantum Fourier transform to n qubit quantum Fourier transform starts with Hadamard gate, ends with the Hadamard gate, followed by the swap gates. And this is represented with the quantum Fourier transform like a Fourier transform. Only difference is 1 upon under root n equal to 0 to 2 raised to power n minus 1, e to the power of j 2 pi nk by n. Based on the above equation, the equivalent quantum circuit representing the QFT is. Now, this very nicely represented, thoroughly explained in the Bible of the quantum computing, which is called M.A. Nielsen and I.L. Chung. Quantum Computation and Quantum Information. The publisher was Cambridge University. It's a very nice book. I would suggest you all people to at least go through this book once if you're really interested in doing something in the quantum computing. Now, what we had done, we had, if you look at this very carefully, many control rotation qubits operations are given. They are required to be decomposed. So the same is given in the M.A. Nielsen book. So a single rotation has to be decomposed into 2 C0 gates with the 3 single units. So this entire mathematics we had presented, we had solved with the help of the M.A. Nielsen book. And we obtained the decomposition of the quantum Fourier transform. The optimization techniques were Ry pi by 2 and minus Ry pi by 2, no rotation, minus Ry pi by 2 and minus Ry pi by 2, pi and 7 pi by 4. This reduce optimize decompose 3 qubit quantum Fourier transform. So we had merged it. So these are the states, reduction in optimization of the qubit quantum Fourier transform. This is magnitude and phase difference for the first order conventional and first order reduced QFT, and modified order conventional, modified order reduced QFT. Same, conventional reduced. Now, for the fidelity, we have used a different formula to obtain the fidelity. It was the same formula was given in the K. Durai and D. Suter, efficient implementation of quantum Fourier transform and experimental perspective for the different states, and fidelity is improved from 99.98 to the 99.9, and last for the 111 99.97 to 99.77. So this is a QFT periodicity estimation. How to estimate the periodicity. So just implemented it. What we have found from the input density matrix of periodicity 4 to the output density matrix of periodicity 2. So it was given in efficient implementations of the quantum Fourier transform and experimental perspective. The quantum computation needs a finite gate set to solve the problem of efficient approximation. The number of elementary gates, T depth and total depth of quantum circuit are 49 and 32. It was nicely presented in a meet in the middle algorithm for fast synthesis of the depth optimal quantum circuits. It was presented in the year 2013. The Clifford plus T gate set based, one more kind of implementation. You could go through it. Reduce decomposition of the Clifford plus T based qubit. Now, one more one more paper we had presented on the comparison or performance investigation of one Toffoli gate full adders. We had considered two Toffoli gates for the full adders, and we presented the comparison. This is the one of the representations of the 4-bit reversible ripple carry adder based on quantum full adder. This design we had presented, and this is the decomposition which we had obtained, optimal decomposition of quantum full adder 1 and quantum full adder 2. So the optimal decomposition of quantum full adder 1, optimal decomposition of quantum full adder 2. So this is the fidelity representation. What we observed, 2 fidelity gate based quantum full adder average fidelity is 97.65. So this is the comparison chart. Conventionally, we had obtained the number of elementary operations around 180 for the 2 fidelity reversible full adder, and for 1 Toffoli reversible, it is from around 140 approximately. It is drastically reduced. So the investigation obtained, the results obtained through the investigation are the achieved optimization number of operations is 5.81% and 7.69% for QFA1 and QFA2 respectively compared to their reduced counterparts. The average fidelities for the QFA1 and QFA2 are 98.34 and 98.21 respectively. The improvement in fidelity is 0.7%, 0.57% for 1 and 2 respectively over the two Toffoli quantum full adder. The execution time and the number of electrons required to realize quantum full adder 2 are more than quantum full adder 1 due to one extra CNOT gate. This is the reason why the execution time is required more for the QFA2. If you go back and see, I'm not able to show it you carefully. Extra C in this 3 are required, in this 4 are required. So extra CNOT is there. So one more work we had presented in one of the papers, a novel design optimization of quantum multiplexer. Quantum multiplexer is a very, very important logic design from the perspective of the reversible Boolean computing. So we had presented design in such a way that it is with the SRM University Chennai. One of the authors was who collaborated with me. So this multiplexer or representative, if I represent the comparison shows that previously the number of CNOT gets required were 2 in different reference 15, 16, 17. I'm not providing the references here, but in our proposed, only one CNOT gate is required. So that is the beauty of this particular design. So entirely the number of operations required to carry out the different complex systems wherein this multiplexer is involved is drastically reduced. So this is the reduction. We have optimized it rather. We have decomposed it and then optimized it. So this reduction in number of operations for the multiplexer decomposition is 18.96%, the number of electrons. So this is a fidelity percentage. This we have realized with the help of the Qiskit also. And the multiplexer decomposition 21.65%. Right? Then one more work is their optimization of control V and V plus gate. Just out of curiosity, we had carried out this work. Otherwise, we had done it. So this work also we had obtained. So this is optimization of control V and V plus gate. This is optimization of control V and V plus gate. So what we observed, the fidelity is increased from 99.62 to 99.64, 99.57 to 99.59, 99.55 to 99.60, 99.50 to 99.55. So with the help of the identity-based rules, we have reduced it drastically. I'm presenting the number of operations. See, the percentage reduction, post-optimization percent reduction in number of operations is for the controlled V gate, it is 15.78% reduction. In controlled V plus gate is 19.23% reduction. So we can say that these are the sum of the results. You can go to this is the optimal controlled V and V plus gate based quantum full adder. So we had optimized it, we had designed it, and we had presented the structure. So just look at this optimal decomposition of quantum full adder, right? So this is the optimization. We have reduced it. This is evolution. You can go through it and what the future of quantum computing is. Let me talk about in brief. IBM is expected to announce a project. Actually, this is a old slide. Probably they would have expected it. Qubits, the processing units of quantum computers, can be built from a variety of technologies, including superconducting circuitry, trapped ions, and photons, the quantum particle of light. In 2021, IBM unveiled one with a record-breaking 127 qubits. In November, it debuted its 433 qubit OPSI processor, and the company aims to release 1121 qubit processor called Condor in 2023. IBM is also expected to debut its Heron processor, which will have just 133 qubits. Heron's qubit will be the highest quality, and crucially, each chip will be able to connect directly to other Heron processors, heralding a shift from single quantum computing chip towards modular quantum computers built from multiple processors connected together, a move that is expected to help quantum computers scale up significantly. This is taken from MIT Technology Review. What's next for quantum computing? What the conclusions are, I have divided it into the different phases. The first phase is interaction between flying electrons and static qubits is improved due to the inclusion of the reflection barrier height to exchange interaction ratio to modify the transmission coefficient matrix. Reduction number of electrons required for single qubit rotation and two qubit entanglement. For single qubit rotation, the component of spin qubit sit along the axis of rotation deviates from reference. It deviates from the reference. It has to be stable there. But because of the interaction effect, it doesn't. For two qubit entanglement, there is increasing the error possibility due to the effect of the ratio. Then we move to the second phase. What we observed, what we concluded rather, existing model based reduced gates have better fidelity and modified model based reduced gates require less number of electrons for the gate realization in comparison to the other forms of realization. What is the third phase? Based on the Boolean computing, Boolean logic computing, fidelity satisfy the minimum number requirement for the fault tolerant operations. The average number of switching activities for optimal decompositions is reduced by 36.81% and 8.68% in comparison to the conventional reduced decomposition respectively. We had envisioned those days, not now, the considerable reduction in architecture power dissipation due to optimal decomposition of the computing blocks. And with the help of this, what we observed, what we concluded, optimal decomposition helped to reduce the overall execution time of the reversible Boolean computing blocks to improve the qubit coherence. What was the fourth phase? The average fidelity of the D latch is close to the fault tolerant fidelity to the qubit state approximation at the end of each clock cycle. Fifth phase, there is a reduction in number of transistor switching activities and the number of electrons required for the realization of the QFT. Spin torque based QFT is able to trace the periodicity of the prepared input states of periodicity 4. Fidelity of spin torque based 3 qubit architecture is more than 99%, which encourages utilizing the spin torque based architecture platform for the realization of complex computing applications, of which quantum Fourier transform is an integrated part. Thank you. Any questions, please ask.
The participants can unmute themselves and ask questions if any. Sir, out of curiosity, just one question.
Yes.
There is a news that our neighboring country is getting a quantum chip through another neighbor. So how far India is
Can you
progressing
specify
in
the
developing
neighbors?
its...
Can you specify the
Yeah, China
neighbors?
is giving it to Pakistan. That is what the news is.
Okay,
So how far India is progressing in developing its own quantum chip?
See, there are different dimensions to this chip technology. Which technology they are using for this chip manufacturing? In quantum computing, if you are talking about the IBM superconducting based chip, the chip is not chip itself. You need to talk about the temperature effect also. You would have seen the IBM based all kind of chip manufacturing. If you have visited the ISC Bangalore, I recently had visited, they are having a lab of 2 qubits only, and they need to have a 7 crores of fridge to cool the qubits. So I don't know what kind of a chip they are giving. I mean, technology, I don't know. So I cannot comment on that.
Good evening, sir.
Yeah, good evening.
Uh, Sir, in the one of the slides, you mentioned that there is a 28 silicon doped with phosphorus. Okay, it is used in the it is used because of long coherence time.
Yeah.
So my question was, are there any other materials which can be used?
See, it depends on what you are doing. Ultimate aim is what in quantum computing, ultimate aim is the coherence time. I need to search
Yes, sir.
for the materials which will provide me the more coherence time so that I can carry out as many number of operations. There are many materials also possible, but what I have covered only phosphorus and silicon.
Yes, sir.
Different isotopes rather. In future also many materials are possible. We need to search for them.
Okay.
Any other question? Participants, ask the
Yes,
question.
participants, if you have any question, then hello.
If you need any help in this regard, you can write a mail to me. Madam has my mail. You can send the queries to my mail. No issue.
Sir, it will be better if you type your email ID in the chat box so that all the
Yeah,
participants will get.
I'm writing. Just a minute. Hold on.
Yeah,
It's a good
thank you, sir.
idea.
Ashish sir, I am audible?
Yes, ma'am. Yes, ma'am.
Okay.
Reached?
Yes, sir.
Yeah.
So if there are no further questions, Sandhya ma'am, you can conclude the session.
Yes, sir. Thank you, Dr. Anand Kulkarni, sir. You have taken again, since it was your last session, again, you revise all the things starting from the basics of quantum, what is quantum, then quantum gates, till to the spintronics. So I really thank you for sparing your valuable time
Thank you,
for
ma'am.
this.
Ma'am, you are not audible. You are not audible.
Yeah. Now I am audible, sir.
Yeah, you are audible now.
Okay.
Yes, madam, you are audible.
Thank you, sir, for sparing your valuable time for this ATAL FDP. And you have really shared your valuable experience, your teaching experience in quantum computing. You have really taken us through different aspects of quantum computing. And it was really a
Yes, ma'am.
knowledgeable and fruitful session for all participants. I really thank you all for sparing your valuable time from management of Vidyavardhini College of Engineering and
Ma'am, you are
all.
not audible.
I'm getting unmuted. Ashish sir.
Sir, it is audible, sir.
Okay, okay.
Okay. So on behalf of Vidyavardhini College of Engineering and management of Vidyavardhini College of Engineering, as well as entire organizing team of this ATAL FDP, and from all participants who participated in this ATAL FDP, I thank you all, sir, and I wish you a good day ahead. Thank you very much.
Thank you. Shall I leave, ma'am?
So just to wait a minute, we have to take a
Sir, thank you.
photograph.
Thanks a lot, sir. Kulkarni, sir. Thank you. Thanks a lot.
Yeah.
Ma'am,
You
we
understood
need
many
to
things?
take.
Sir, actually, we
Yeah,
all
yeah.
are in learning phase of quantum computing.
Yeah, I understand.
Participant, please turn on your cameras for a second so that we can take a photograph. Thank you, participants.
Yeah, thank you, sir.
Yeah. Shall I leave?
Yes, sir, you can. Thank you.
Thank you. Thank you. Bye.
Participants, please stay online for further announcements. We will get back to you in 2-3 minutes. Participants, we will start with the validity function at 6:30. Please note, we will start the validity function at 6:30.
Hello, Bharti madam. Hello.
Yes, ma'am. Yes, ma'am.
Okay, start the function.
Yes, ma'am. Am I audible?
Yes, yes, madam.
Okay, ma'am. Good evening to all the dignitaries, Principal Dr. Rakesh Himte sir, Dean Academics Dr. Gupta, HOD EXTC Dr. Ruperi, colleagues and enthusiastic participants. I, Mrs. Bharti Gondharekar, Assistant Professor, on behalf of the department and college, welcomes you all for the validatory function. Over the past 6 days, this FDP has been a platform for learning and intellectual exchange. We are privileged to gain valuable insights from eminent speakers. Now I request our principal sir to share a few words on this occasion.
Good evening. I'm audible.
Yes, sir.
Yeah,
Yes,
very
sir.
good. Yeah, good evening. In academics, Dr. Gupta, head of the department electronics, Dr. Amruta Rupeti madam, all the faculty members of electronics department, and all the participants. On behalf of the institution, I welcome you all, and I'm very happy to see that there is a huge participation from the all the institutions across the pan India. So we all are gathered here in this validatory function of this AICT ATAL FDP on the quantum intelligence, exploring the convergence of quantum computing and artificial intelligence. So all the faculty members knows about this. Everywhere we are using the term artificial intelligence, the application of this AI in engineering and technology. So I'm very much confident. All the sessions were excellent. It was conducted by the academicians from the IITs, NITs, and the industry persons as well, and especially from the STAT. So it was a complete attempt to bridge the gap in the industry and the institution. And I hope whatever you learn about this quantum intelligence, it will be implemented in your classroom, and your students will be get benefited out of this faculty development program. So I won't take your much time. It was a long activity of the last 5 days. So I congratulate the electronics department for organizing such a fantastic program and arrange the experts from the industry as well. So it is a big applause for the electronics department and a big congratulations to all the participants. So I wish you all the best. Thank you so much.
Thank you, sir. Thank you
Thank
for
you,
your
sir.
constant guidance. Now, we moving further. I request our HOD and the coordinator of the program to share a few words.
Thank you, Bharti madam. Respected principal sir, all the faculty members and my dear friends, a very good evening to one and all. Today, as we gather for this validatory function, it is a privilege to speak on the topic quantum intelligence, exploring the convergence of quantum computing and artificial intelligence. This topic is important because it shows how the future depends on learning new ideas and connecting different technologies. As faculty member, we should always remain curious, open to change, and ready to learn and adapt new technologies. Artificial intelligence has already changed the way we live, learn, and work. From personalized recommendations to automated systems, AI has become an important part of our daily lives. However, even with its great power, AI has limitations when it comes to solving very complex problems. This is where quantum computing plays a key role. As we learned from the sessions, quantum computing is based on the principles of superposition and entanglement. It offers a completely new way of processing information. When quantum computing is combined with the artificial intelligence, it gives rise to what we call quantum intelligence. Quantum intelligence has the potential to speed up the machine learning, optimize complex systems, improve climate modeling, and strengthen the cybersecurity. It is not just about faster computing, but about making smarter and better decisions. This presents a major steps forward for science, technology, and society. As our students step into the future, they are entering a world where subjects no longer exist separately. Innovation happens when ideas come together. Quantum intelligence teaches us the importance of curiosity, teamwork, and the courage to explore the unknown. It reminds us that the future belongs to those who are willing to learn continuously and adapt the change confidently. On this special occasion, let us carry forward the spirit of exploration and innovation. Let us dream big, think critically, and use technology responsibly for the benefit of society. I take this opportunity to express my sincere gratitude to AICT for giving us this valuable opportunity. I would like to thank our management and our principal, Dr. Rakesh Himte, for their constant motivation and encouragement. I also thank deans and all the head of the department for their guidance. I would like to appreciate the efforts of our co-coordinator, Ms. Shaista Khanam and Ms. Neha Garat, and Ashish Vanmali and all the faculty members of the department, without whom this event would not have been possible. I sincerely thank all the eminent speakers from the IITs, NITs, CDEC, Deloitte, IBM, and other industry for sharing their valuable time and the knowledge. Their clarity and depth of understanding greatly enrich this program. Thank you all. Finally, I would like to thank all the participants for attending the session sincerely. Thank you all for your patience and attention. I wish everyone a bright, successful, and meaningful future. Thank you, everyone. Thank you all.
Thank you, ma'am,
Over
for your
to
constant
Bharti, madam.
support. Yes, ma'am. Thank you so much for your constant support and guidance. So thank you one and all who has made this program a huge success. There's a small note. Uh, Feedback and exam on ATAL portal is essential criteria for receiving certificates. So participants kindly take note of this. And with this, we end the function here, the validatory function here, and a happy
Wait, ma'am, wait,
learning to
Bharti,
everyone.
Bharti,
madam.
madam, wait a minute. Bharti,
Yes,
Wait a
madam,
ma'am.
wait.
minute.
Ashish,
Yes,
sir,
ma'am. Yes,
continue.
ma'am.
Yes.
Yes, ma'am.
We are almost at the end of the function, but the success of FDP is not possible without participants. And we received a huge participation in this particular FDP. So now it's time for the participants also to share their views because they have been there for last 6 days and attending the 13 different sessions that we are organized. So before we end this function, it is very likely to hear about this organization of this function from the participants. So please share your feedback. The floor is open to you so that we can improve upon organization of such kind of activities in future. So any participant
Participant,
who
you
wish
can
to,
unmute yourself and share your feedback.
and please turn on the camera also so that we can record it.
Camera, sorry, sir, but I'm Dr. Madhavi from KL University, Hyderabad. All the sessions went very well. We did not feel that it was late evening and even morning we're able to again go to the colleges and do our work pleasantly because sessions are very interesting, and especially the hands-on experiences which they have shown, simple experiments, and starting from the scratch they have been explained to us, starting from what was a qubit and dynamics, qubit dynamics also have been explained, quantum dynamics also have been explained by the all the faculty who are teaching us. That is also very nice. Faculty was very slow without seeing the time bounds. They have explained to us, and especially the Q universe and then the Qiskit programs which they have shared to us also very nice. And the content communications part, my research area is quantum communications. So I enjoyed all the 3 sessions very well. Starting from the teleportation to quantum entanglement, they have explained us, and also even I know about the how the shared key will be prepared, but the way the faculty was explaining about that, it's really very interesting, and I really enjoyed all the sessions. And today, especially the variational quantum circuits and parameters quantum circuits, very interesting. And the last session where quantum computing, sir, was explained for a very new topic for me, that I also enjoyed very much. And the federated learning and how the data will be used, quantum federated learning, they have been explained to us. That is also very, having both theory and practical blending is a very real experience, new experience I had got to this particular FDP. Thank you for giving me this opportunity to participate in the FDP and learn and refresh my concepts again. Thank you very much.
Thank you, madam. Thanks a lot.
Shardul sir, will you like to share your views on this? Anyone else who will like to share their views on the overall conduction of the FDP?
And I missed one point. Thanks for the organizers too for organizing, bringing such very good resource persons and making this very successful. Thank you.
Yeah, thank you, ma'am. Any other participants who want to share their views? Okay, so we can then conclude the session, but before that, there are a few announcements. Okay, the first thing is every participant will have to log in to ATAL portal and give feedback and attend a quiz over there. We will release the quiz at 7:30, and the quiz will be for 50 questions, and you have 1 hour to attend that particular quiz. So criteria are already shared regarding the marks one needs to score in the quiz to get the certificate. But both these are mandatory. Of course, we will submit the attendance from our side. But apart from that, every participant need to give feedback on the ATAL portal and also attend the quiz over there, which will be released at 7:30. Okay. So best of luck to everyone. Okay. Please attend the quiz on time so that you can attend all the questions and score over there.
Ashish sir, I think we should take a photograph.
If participants are available over there, please turn on your cameras so that we can take the last photograph for the day.
Yeah, 80 participants are there.
Yeah, please turn on your cameras. We will have a last photograph because this is the last session and we are going to conclude it now.
Thank you, Principal Sir. Thank you, Amrita Madam. Thank you, Trupti, and thank you, Department. You have very nicely organized this FDP. It was very well planned, and all the resource persons were very I can say experienced and resourceful.
Thank
Yeah,
you,
thank
ma'am.
you, ma'am.
Thank you, Srishti
Thank you,
madam.
ma'am.
Yeah, it is done. Thank you, everyone.
Thank
So
you.
let's conclude.
Thank you,
And
Ashish.
yeah, let's
Thank you
join back
everyone.
at 7:30 on the ATAL portal.
Happy learning to everyone.
Thank you.